Hi guys, so today we'll be solving the first problem of April LeetCoding challenge. Let's solve it. Palindrome linked list. Given the head of a single linked list, return true if it is a palindrome. Head is equal to 1221, so this is a palindromic linked list, therefore we return true. And similarly 12 is not a palindrome, therefore we return false. So basically we've been given a linked list and we need to return if it is a palindrome then true, and if it is not a palindrome then it false. So let's try to solve it. Basically the approach would be just to like treat it as a linked list, as an array, and do the fair share of what we do in array. Similarly we need to uh, code it here. So let's try to solve it. So we know that the base condition would be head is equal to null pointer, or head next is equal to null pointer, then we return true. So if there's no element in the linked list, or there's only one element in the linked list, then it is supposed to be a palindrome. All right. Then we'll create a node mid, where we'll be creating a function middle node which will give us the middle of the linked list. So let's create that middle node function. So list node star middle node, list node star head. So here the base condition would be if head is equal to null pointer, or heads next is equal to null pointer. At this time we return head. All right. And now we'll be using the runner technique that we all know how to use, that we'll be making one pointer run by 1 and the other pointer run by 2. So let's do that. Just slow be head, and let the pointer fast be also equal to head. Now we'll create the function loop where if fast next is not equal to null pointer, and uh, fast next is not equal to null pointer, at that time we run slow next fast is equal to fast of next. All right, this is how we do, and then at the end we return slow. All right, now let's move ahead. Now we know that we got the middle of the linked list, so we'll be dividing the linked list into two parts. So let the middle next be equal to null pointer. Okay, so one more, we'll create a tail head which should be middle next. All right, and let the middle next be null pointer. Now tail head, let's reverse the tail head so that we can compare the tail head linked list and the linked list from the start till the middle that we have. When we compare both of these, we know that if it is a palindrome we get the result, we know that the value would be similar, so we'll be using the same thing what we use in arrays. So we'll reverse it calling the function reverse node, and we'll pass head t head to it. All right, now let's make the reverse function here. Reverse node list node star head. Now the same base condition, if head is equal to null pointer, or heads next is equal to null pointer, at that time we return head. All right, and now how we're going to reverse it, we will be using three pointer technique, that we uh, have to basically keep a forward pointer, keep a current pointer, and keep a previous pointer. So forward will be pointing to the next element, previous So basically the current pointers next would be equal to the previous, and we would be incrementing current to forward, and we will be basically using the same technique to keep on going and pointing the current element next as the previous element. So we keep a count of the previous one, we keep a count of the current one, and we keep a count of the forward one. As and when we are on the current, we keep make the currents next is equal to previous, and basically we move the current pointer to forward, and now forward will be moving to forwards next. All right, now previous will become current. Okay, this is the basic technique that we need to follow throughout the linked list. Okay, let's code it. Let's node star current be equal to head. Let's node star forward will be equal to null pointer. So first we don't initialize anything because we know that it's at the first node it will be null pointer. All right, now let's while current next is not equal to null pointer. All right, now let's run the loop that what we discussed. So let forward be equal to currents next. Okay, currents next, let it be equal to previous. Current next, let it be equal to previous should be equal to current, and current should be equal to forward. All right, this is what we discussed, right? And then we return previous. All right, at this time the whole linked list would have been uh, reversed. Now let's create two pointer to run through the reversed list and the normal list that we have right now. C2, let it point to T head, which is the reverse list. Now while C1 next is not equal to null pointer, and C2 next is not equal to null pointer, till that time if C1's val is not equal to C2's val. Okay, so let me create a Boolean variable result, let it initialize to 2, and we'll be making it here false. All right, and then we'll be breaking it, and we'll be doing here C1 is equal to C1 next, C2 is equal to C2 next. Now we have the answer, which tells us if both of the reversed list and the normal list are equal. But now we have to make basically we have to return the result. But before that we need to get back the reversed linked list in the form as it was. So we will be calling Thead is equal to reverse node Thead again, so that we get the uh, reverse node back, and middle next should be equal to Thead. All right, this will give us the uh, reversed linked lists as back as it was. So let's run the code to see if everything is working fine. Yeah, okay, there's a mistake. 1 comma 2 should return true. Okay, all right, we probably missed this one. hmm. Null pointer of type. Okay, hmm. Fastnet is not equal to, wait. Hmm. Well, current is not equal to null pointer. This should go 1, 2, right? Let me see. True. True, but false. Okay. Mm-hmm. Why is this happening? 1 and 2. We have 1. We reverse 2. Okay. C1 is not equal to null pointer. Yeah. Let's see. 1, 2, 2, 1. This is false. Did we do any mistake here? C1 is not equal to null pointer. Okay, 1, 2, 2, 1. So this one. 2. Yeah, that works. So basically here we know that current should be reaching the last element equal to the null pointer. We know that we have the previous covered, so we will return previous here. Therefore, we don't need to worry that current should be one less than the current null pointer. We can reach the last pointer, and we know that the previous is saved. So that's why. So I hope you guys understood the problem. Thank you.